Welcome to the Bedtime Lab, where we gently drift into the realm of wonder and curiosity, exploring the universe like old friends. It's a special space where we can unwind and let our minds wander freely among the stars. Tonight, let's dive into the enchanting world of habitable zones around stars, a topic that brings together the mystery of the cosmos and the warmth of bedtime stories. Before we begin, I'd love to know where you're listening from. It's amazing to think about how each of us is nestled in our own little corner of the world, yet connected by the same night sky. Feel free to share your location in the comments, if you'd like. It's always such a delight to see where our community of dreamers is tuning in from. Now, imagine this. A habitable zone, often called the Goldilocks zone, is a region around a star where conditions might just be right for life as we know it. Not too hot, not too cold, but just right for liquid water to exist. Speaking of which, did you know that our own Earth sits snugly in the Sun's habitable zone? It's one of the many reasons we're able to enjoy the vibrant life that flourishes here. Here's an interesting fact. These habitable zones aren't the same for every star. For stars that are cooler and dimmer than our Sun, their habitable zones are closer, almost as if they're huddling near a campfire to stay warm. In contrast, for stars much hotter and brighter than ours, these zones stretch far out, as though the planets are keeping their distance from a blazing furnace. Have you ever wondered if there might be planets out there similar to Earth? Scientists have discovered thousands of exoplanets, some of which lie within their star's habitable zone. And here's something truly fascinating. Among these, a small but intriguing fraction are rocky planets like our own, possibly with the right conditions for life. Now, consider this. The concept of a habitable zone extends beyond just water. It also involves the right atmospheric pressure and chemical composition necessary for life. Can you imagine the delicate balance required to maintain such conditions? It's like a cosmic recipe where every ingredient must be measured with exquisite precision. Another captivating thought: stars are not all solitary travelers through space. Many are part of binary or even triple star systems. Picture this. Planets orbiting in these systems might experience not just one sunset, but two or three, painting the skies with a breathtaking array of colors. The habitable zones in these systems are complex, shaped by the gravitational ballet of multiple stars. As you drift deeper into this celestial exploration, it's worth noting that the size of a star can drastically alter the habitable zone. For massive stars, the zone is vast but fleeting, as these giants burn through their fuel quickly and have much shorter lifespans. Meanwhile, smaller stars, known as red dwarfs, have more stable and enduring habitable zones, offering a prolonged window for potential life to develop. Did you know that some scientists are considering the possibility of habitable moons, just like Jupiter's moon Europa and Saturn's moon Enceladus, which are icy but show signs of subsurface oceans? These moons, if orbiting planets within the habitable zone, could harbor environments where life might thrive. Here's another gentle thought to ponder. The elements that make up our world were forged in the hearts of stars. In the ashes of stellar explosions, these elements are scattered across the cosmos, eventually coalescing to form new stars and planets. This cosmic recycling hints at the possibility that habitable zones could be more common than we once imagined. Now let me share something curious. Even if a planet lies within the habitable zone, it doesn't guarantee the presence of life. So many factors come into play, from the planet's atmosphere to its magnetic field, which protects it from harmful solar radiation. It's a delicate dance of probabilities where the universe seems to be both vast and selective. Speaking of chances, did you know that our galaxy, the Milky Way, could host billions of planets within habitable zones? This staggering number fuels our imagination and encourages the search for life beyond Earth. It's a reminder of how small yet significant we are in this vast cosmic tapestry. As we continue, think about this. Detecting these distant worlds and their habitable zones is like piecing together a cosmic jigsaw puzzle. Instruments like the Kepler Space Telescope have revolutionized our understanding, revealing the diversity of planetary systems. It's as if we've opened a window to a universe teeming with possibilities, each discovery inviting us to dream a little bigger. And here's something to dream about. The study of habitable zones not only deepens our understanding of other worlds, but also enriches our appreciation of Earth. Our planet is a rare gem, a sanctuary of life in a universe that can be both nurturing and harsh. It's a reminder to cherish and protect this world we call home. As you let these thoughts gently swirl in your mind, I invite you to relax and imagine the countless stars and their potential habitable zones scattered across the universe. Each one is a beacon of curiosity, a reminder of the endless possibilities that await us in the vast expanse of space. Drift softly into sleep, knowing that the cosmos holds mysteries yet to be discovered and dreams yet to be dreamed. Let your mind wander to a distant star, where a planet orbits in gentle harmony. Did you know that the concept of a habitable zone isn't confined to a static region? These zones can shift over time due to the star's life cycle. Stars evolve, growing brighter and hotter, which means the habitable zone around them can gradually drift outward. Imagine a planet once comfortably nestled in its star's habitable zone, slowly finding itself too warm as the star ages and brightens. It's as if the cosmic conditions continually change, like seasons on a grand universal scale. Here's a thought that might intrigue you. While we often focus on planets, the moons orbiting these planets can also find themselves within habitable zones. In these instances, the parent planet acts as a kind of gravitational anchor, potentially allowing life-supporting conditions to exist on their moons. This expands our search for life beyond planets alone, adding another layer of complexity and wonder to our understanding of habitable zones. Consider this. In some binary star systems, where two stars orbit one another closely, the habitable zone can become a twisting, dynamic ring. The interplay of gravity and radiation from both stars creates a dance more intricate than a waltz, requiring careful calculations to determine where life might feasibly sustain itself. These cosmic ballets offer a hint at the universe's penchant for complexity and beauty. And did you know that the size and type of a planet within a habitable zone can greatly influence its potential to harbor life? Larger planets, known as super-Earths, may have thicker atmospheres, offering better protection from harmful solar radiation and retaining heat more efficiently. This could mean a more stable environment for life to emerge, akin to a cozy blanket wrapped around the planet. Here's something to ponder. The gravitational pull from a massive nearby planet can impact the habitability of another body nearby. This is particularly true in tightly packed planetary systems, where the gravitational influence of large planets can cause shifts in the orbits of smaller, potentially habitable worlds. It's a reminder that celestial bodies are not isolated, but interact with each other in a cosmic web of connections. Speaking of connections, let's explore the idea of tidal locking. When a planet is tidally locked, it shows the same face to its star, much like how the moon shows only one face to Earth. This creates a permanent day side and an eternal night side. You might think this would make the planet inhospitable, But there's a region along the twilight zone known as the Terminator line where conditions could be just right for life. It's a thin band of habitability, balancing between extremes. Let me share another fascinating aspect, the albedo effect. This refers to how much light and heat a planet reflects back into space. A planet with a high albedo, like a world covered in ice, might appear colder and extend the boundaries of its habitable zone closer to the star. On the other hand, a darker planet that absorbs more heat could push the habitable boundaries outward. It's like the planet's surface is painting its own climate canvas. Have you ever imagined a planet where weather patterns are driven by the planet's rotation and axial tilt? These factors can create diverse climates across a world, even if it's uniformly positioned in the habitable zone. For instance, a tilted axis can result in pronounced seasons, while a rapid rotation might lead to dynamic weather systems. Such planets could host a mosaic of environments, each with their own potential for life. Here's a gentle reminder of the delicacy of our universe. Even a small change in a star's energy output can shift the habitable zone significantly. For instance, a minor increase in stellar luminosity could push a planet out of the habitable zone, making it too hot for liquid water. Conversely, a decrease could lead to a frozen world. This illustrates the finely tuned balance required for life as we know it to thrive, showing us how precious and precarious these cosmic cradles are. Can you imagine a planetary system with a trio of stars? In such systems, the habitable zone would be a place of intricate gravitational influences, with stars pulling and tugging on each other and on potential planets. The possibilities for habitability in such a dynamic environment are both complex and tantalizing. And here's something that might surprise you. Stars themselves are born in clusters, surrounded by a cloud of gas and dust. As they form and disperse, the potential habitable zones within these clusters can be influenced by the proximity of other stars. This means that the early life of a star can have a profound impact on the habitability of its planets, as if the star's birthplace imprints a cosmic signature on its future. Imagine the interplay of magnetic fields within these zones. A strong magnetic field on a planet could protect it from stellar flares and radiation, much like Earth's magnetic field shields us from solar winds. This protective cocoon is crucial for maintaining a stable environment where life might flourish. As your thoughts drift with the stars, consider the role of plate tectonics. On Earth, this geological activity is vital for recycling carbon and maintaining a stable climate. If a planet within a habitable zone has active tectonics, it could bolster its chances of supporting life by regulating atmospheric conditions over geological timescales. It's a reminder that even beneath the surface, a world might quietly support the tapestry of life. Finally, as we continue our journey through the cosmos, keep in mind that the search for habitable zones isn't just about finding new worlds. It's about understanding the delicate dance of physics and chemistry that allows life to exist. Each discovery, each insight, brings us closer to answering one of humanity's oldest questions. Are we alone? In the vast expanse of the universe, habitable zones are not just scientific concepts, but a testament to the boundless possibilities of life beyond Earth. As you drift into a peaceful slumber, let the mysteries of these celestial sanctuaries fill your dreams with wonder and hope for what lies beyond the stars. Let me transport you to the realm of binary star systems, where two stars dance around each other in a cosmic waltz. Did you know that planets within these systems can experience a unique kind of habitable zone? Depending on the distance and mass of the stars, habitable zones can vary, creating a delicate balance where a planet might orbit both stars or just one. This interplay can lead to unusual climate patterns with the potential for spectacular double sunrises and sunsets. Such a world would be a marvel to behold. Speaking of intriguing scenarios, consider a planet orbiting a red dwarf star. These cool, dim stars have been the focus of intense study because of their longevity. A surprising fact is that their habitable zones are much closer to the star compared to our Sun. This proximity can expose planets to stellar flares, which are intense bursts of radiation. However, if a planet possesses a strong magnetic field, it might shield life from these flares, offering a protective barrier. Imagine the resilience required for life to thrive under such conditions. Now, let's journey to the concept of eccentric orbits. Unlike the nearly circular path Earth takes around the Sun, some planets have orbits that are more elliptical. This means they vary in distance from their star throughout the year, experiencing dramatic changes in temperature. Such planets might spend part of their orbit within the habitable zone, with potential for life during these periods of milder conditions. It's a fascinating rhythm, akin to a seasonal dance with their star. Consider the notion of rogue planets, which are planets that don't orbit any star, drifting through the galaxy. While they lack a star's warmth, if they have a thick atmosphere rich in hydrogen, they might retain enough heat to host life beneath their surface. This heat could come from internal sources like radioactive decay or residual heat from formation. It's a captivating thought that even in the depths of space, life might find a way to exist. Another interesting consideration is the impact of giant impacts. These cataclysmic collisions can drastically alter a planet's environment, possibly moving it into or out of a habitable zone. Such events could create moons, which might themselves harbor life, or dramatically change a planet's climate. It's a reminder of the ever-changing nature of our universe and how dynamic forces can shape the potential for life. As we journey through the cosmos, let's pause to appreciate the role of atmospheric composition. A planet's atmosphere is crucial in determining its surface conditions. For instance, an atmosphere rich in greenhouse gases could trap heat, keeping a planet warmer than its distance from its star might suggest. This could extend the habitable zone further out, allowing for a wider array of potential homes for life. It's like nature's own thermostat, finely tuning the environment. Imagine planets in the habitable zones of massive stars. These stars, though bright and hot, have much shorter lifespans than our Sun. Habitable zones around them are fleeting, offering only a brief window for life to emerge and evolve. The universe is full of such fleeting opportunities, where the right conditions align only momentarily. It's a cosmic reminder of the preciousness of time. In contrast, planets around older stars nearing the end of their life cycle might find themselves within a newly expanded habitable zone. As stars age, they swell and cool, potentially moving their habitable zones outward. This means that a once frozen planet might suddenly find itself bathed in warmth, opening up new possibilities for life. It's a beautiful example of transformation, where change brings fresh opportunities. Did you know that the shape of a planet can influence its habitability? A planet with a significant equatorial bulge, caused by rapid rotation, could experience varied gravitational forces. This might lead to unique atmospheric dynamics, with winds and weather patterns shaped by its unusual form. Such a planet would offer an intriguing tapestry of climates, each with its own potential for life to find a niche. Speaking of climate, consider the role of oceans. On Earth, Oceans are vital in regulating climate and are thought to be crucial for life. A planet with a vast ocean could distribute heat more evenly, creating a stable environment. This could extend the habitable zone by mitigating extreme temperatures. It's a soothing thought, the gentle ebb and flow of tides playing a part in nurturing life. As you ponder these cosmic wonders, think about the role of moons. Large moons can influence the habitability of a planet through tidal forces, which might drive geological activity and even help stabilize a planet's tilt. This, in turn, could create a more stable environment for life. Moons, often seen as companions, play a subtle yet significant role in the cosmic dance of habitability. Lastly, let me share a notion about cosmic rays. These high-energy particles, originating from outside our solar system, pose a challenge to life. In some cases, a planet's magnetic field or atmosphere may offer protection, allowing life to thrive despite these harsh conditions. It's a testament to the resilience of life and the myriad ways it can adapt and endure amidst the cosmic elements. As you drift deeper into the universe's embrace, remember that habitable zones are more than just a place in space. They're a concept that invites us to imagine the infinite possibilities of life, to dream of worlds yet unseen, and to hold hope in the vastness of the cosmos. Let the stars guide your dreams as the wonders of the universe cradle your imagination. Did you know that some stars can actually host multiple habitable zones? Imagine a system where planets orbit at different distances, each with its own ring of potential habitability. This is more likely in systems with multiple stars, where their combined gravitational pull and light can create several zones where life might thrive. It's a delicate balance, like a cosmic orchestra playing a symphony of life. And here's something intriguing. Habitable zones are not just for planets. Moons orbiting giant planets in these zones might also harbor life. Picture a moon with its own atmosphere and oceans, warmed by both its planet's heat and its star's light. Such moons could even surpass their planets in habitability, offering unique environments where life could evolve in extraordinary ways. Speaking of moons, consider the tidal heating effect. When a moon is in a close orbit around a giant planet, gravitational forces can cause its interior to heat up, potentially keeping it warm enough to support life. This internal warmth could sustain liquid water beneath an icy surface, creating a hidden ocean world. It's a reminder of the unseen possibilities lying beneath the visible surface of the cosmos. You might be surprised to learn that habitable zones can exist around brown dwarfs, which are often called failed stars. Despite not having the mass to ignite nuclear fusion like regular stars, brown dwarfs can still emit enough heat to maintain a habitable zone. Planets within this zone could experience gentle autumn-like conditions, with the warmth coming from residual heat of the brown dwarf's formation. It's an example of how life might find a way, even in the most unlikely places. Here's a fascinating thought. The color of a star can influence the vegetation on a planet in its habitable zone. While Earth's plants are green due to absorbing red and blue light, plants on planets orbiting stars with different spectra might be a whole spectrum of colors. Can you imagine forests of deep red, purple, or even black foliage? It's a kaleidoscope of possibilities where evolution paints with a different palette. Now, let's consider the role of planetary axial tilt. A planet with a significant tilt might experience extreme seasons, yet this very tilt could promote biodiversity. The varied climates would challenge life to adapt in numerous ways, potentially leading to a rich tapestry of ecosystems, like a world constantly adapting to the rhythm of its dance around a star. life finds myriad ways to flourish. Another intriguing aspect of habitable zones is the concept of atmospheric escape. A planet too close to its star might lose its atmosphere over time due to solar winds, but some planets, with strong magnetic fields or heavy, dense atmospheres, could resist this erosion, maintaining the right conditions for life. It's a testament to the tenacity of worlds in the face of relentless stellar forces. And did you know that the presence of a large protective gas giant in a solar system might enhance the habitability of planets in its vicinity? These giants can serve as cosmic shields, deflecting or capturing comets and asteroids that might otherwise impact smaller, potentially habitable planets. It's like having a big brother watching over a younger sibling, ensuring their safety in the cosmic playground. Consider a scenario where a planet has an orbit that causes it to spend time outside a star's habitable zone. During its journey through the cold depths of space, it might enter a period of dormancy, only to spring back to life when it re-enters the warmer zone. This cycle of life and dormancy could lead to fascinating evolutionary adaptations, making life incredibly resilient and adaptable. Imagine the effect of stellar variability on habitability. Some stars, known as variable stars, fluctuate in brightness over time. Planets orbiting these stars might experience periods of warmth followed by cooler times, challenging life to adapt to these changing conditions. It's like the universe playing with a dimmer switch, offering a dynamic environment for life. Here's a captivating thought. The chemical composition of a planet's surface can affect its habitability. Planets with surfaces rich in metals like iron might have unique climates and geological features. This could influence the types of life forms that evolve, leading to ecosystems unlike anything we know. It's a reminder of how every element, every grain of dust, shapes the potential for life. Speaking of compositions, think about the role of volcanic activity. Volcanoes can release gases that build an atmosphere, potentially warming the surface to habitable conditions. They also contribute to geological diversity, creating fertile ground for life to take root. Imagine a world where volcanic islands dot the seas, each a cradle for life, nurtured by the fiery heart of the planet. And finally, let me share the intriguing concept of synthetic habitable zones. As our understanding of planetary environments grows, scientists ponder the possibility of altering a planet's environment to make it more habitable. This might involve introducing specific gases to the atmosphere to create a greenhouse effect, or even redirecting comets to add water. It's a bold idea, suggesting that one day we might not just search for habitable worlds, but create them. As you reflect on these wonders, let your thoughts drift through the cosmic tapestry, where every star, planet, and moon holds the promise of life. In this grand universe, the possibilities are as endless as the stars themselves, each twinkling light a beacon of hope and discovery, guiding your dreams into the vast unknown. Let's continue our dreamy exploration with more captivating thoughts about habitable zones. Imagine worlds where ring systems, much like those of Saturn, could influence the climate of a planet. These rings might reflect sunlight back onto the planet, providing additional warmth or even helping to regulate the temperature by casting shadows. It's like having a cosmic thermostat, adjusting the environment with the gentle sway of celestial jewelry. Have you ever considered the whisper of a cosmic wind? In systems where stars are close enough to interact, they can transfer material and energy through stellar winds. This exchange might enrich the atmospheres of planets within the habitable zones, providing essential nutrients and energy. Picture the planets dancing in an interstellar breeze, their skies alive with the subtle glow of shared starlight. Here's something intriguing: the presence of water worlds. These are planets completely covered by oceans, with no land in sight. On such worlds, life might develop in the deep, dark waters, relying on hydrothermal vents for energy. It's a world where sunlight never touches the seabed, yet life thrives in the warm, mineral-rich embrace of the planet's belly, creating ecosystems that could be teeming with unique, aquatic life forms. Speaking of water, imagine planets where the hydrological cycle is vastly different from Earth's. On these worlds, rain might only fall once every few decades, leading to long dry spells followed by brief periods of abundant water. Life on such planets would need to be incredibly resilient, adapting to survive with minimal resources. It's a testament to the endurance of life in the face of scarcity. Consider the fascinating role of snowball planets. These are planets that have frozen over entirely, yet beneath their icy shells, warmth from geothermal activity might sustain hidden oceans. It's a world where life, if it exists, would be isolated in pockets beneath the ice, a testament to survival against all odds. Imagine explorers drilling through kilometers of ice to find vibrant, thriving ecosystems below. Now let's ponder the concept of planets orbiting in binary star systems. With two suns, these planets could experience double sunrises and sunsets, bathing them in golden light from multiple angles. The climate on such worlds could be more stable than you might expect, with the gravitational interplay of two stars creating a unique balance. It's like a cosmic waltz, with planets gracefully gliding between twin sources of warmth and light. Have you ever thought about worlds with mirrored surfaces? Planets with highly reflective surfaces, such as ice or clouds, might reflect so much sunlight that they remain cooler than expected. This albedo effect could allow them to exist comfortably within the habitable zone, even if they are closer to their parent star. Imagine standing on a planet where the ground glitters like thousands of tiny mirrors, casting the star's light in every direction. Speaking of reflection, consider planets with dense, cloudy atmospheres. These clouds might trap heat, creating a greenhouse effect that warms the planet. It's a delicate balance, where too many clouds might overheat the world, but the right amount can make it a perfect cradle for life. Imagine a sky perpetually overcast, yet teeming with life, the clouds nurturing the biosphere below. Did you know that the age of a star can influence the habitable zone? Young stars are often more active and emit strong stellar winds, which could strip a planet's atmosphere. However, as stars mature, they tend to stabilize, providing a more consistent climate. This means that planets orbiting older stars might have more stable conditions conducive to life. It's like waiting for the perfect moment when the storm has settled and the calm sets in. Imagine a planet with a strong magnetic field, which can protect its atmosphere from being stripped away by solar winds. This magnetic shield could also create stunning auroras, painting the skies with ribbons of light, much like Earth's northern lights, but far more spectacular. It's a dance of color in the heavens, a celebration of life's resilience in a cosmic arena. Consider the idea of tidal locking, where one side of a planet always faces its star, while the other remains in perpetual darkness. You might think such a world would be too extreme to support life, but the boundary between light and dark, known as the terminator line, could be habitable. Here, temperatures might be just right, and life could thrive in the twilight zone, forever balanced on the edge of day and night. Let's not forget the influence of super-Earths on habitability. These are larger than Earth, but smaller than ice giants like Neptune. Their strong gravity could allow them to hold on to thick atmospheres, potentially making them more habitable than smaller planets. Imagine walking on a super-Earth, where the skies are vast and thick with clouds, each breath a testament to the planet's protective embrace. Visualize a world where meteor impacts have reshaped the landscape, creating a unique environment for life to develop. These cosmic collisions could bring water and organic compounds, sparking the beginnings of life. It's a reminder of the chaotic beauty of the universe, where destruction can lead to creation and life finds a way through the debris of cosmic events. And as we drift back into the celestial seas, consider rogue planets which wander through the galaxy untethered to any star. Some theorize that these planets, if they possess enough internal heat and atmosphere, could potentially harbor life. They are the wanderers of the cosmos, carrying the seeds of life through the dark void, a testament to the boundless possibilities of our universe. Each of these musings speaks to the vast potential for life beyond our world, where the universe's many wonders play out their timeless stories. These ideas, like gentle whispers of the cosmos, invite you to dream deeply, to explore the possibilities that stretch far beyond the reaches of our imagination. Imagine the wonder of planets orbiting pulsars, the remnants of massive stars that have gone supernova. These pulsars emit beams of radiation that sweep across space like cosmic lighthouses. Although it might seem improbable, the idea of a habitable zone around such a dynamic star isn't out of the question. If a planet were to maintain a strong magnetic field and atmosphere, it might shield life from intense radiation, much like an invisible cloak. What a curious place that would be, with night skies potentially lit by the rhythmic flicker of pulsar beams. Speaking of stars, consider red dwarfs, the most common type of star in our galaxy. These stars are much cooler and smaller than our Sun, and their habitable zones are proportionally closer. Planets in these zones may be tidally locked, with one side always facing the star. Yet, life could thrive in the twilight areas, where temperatures remain stable. The slow and steady nature of red dwarfs means they can burn for trillions of years, offering a long window of opportunity for life to evolve. Imagine the ancient wisdom such a world might hold, nurtured by a star's gentle glow for eons. Here's a fascinating thought. Planets with eccentric orbits, where the distance from the star fluctuates dramatically over time. Such planets could experience intense seasonal changes, with periods of blooming life during closer passes to the star, followed by long icy winters. Life on these planets might adapt to these cycles, lying dormant during harsh times and bursting into activity when conditions improve. It's a reminder of nature's resilience, finding harmony in the dance of celestial mechanics. And did you know that some stars have habitable zones where multiple planets might coexist? Imagine a solar system where several planets, each within the habitable zone, share the warmth of their parent star. These worlds could support diverse ecosystems, each unique but linked by their shared orbit. It's like a cosmic community garden, where life thrives under the same nurturing rays. Speaking of nurturing, think about the concept of exomoons, moons orbiting planets in habitable zones. These moons could themselves be habitable, boasting lush landscapes and vibrant atmospheres. Imagine standing on a moon, gazing up at its host planet, dominating the sky, a constant and mesmerizing presence. Such a beautiful relationship between planet and moon could foster environments teeming with life, each enriching the other in a cosmic embrace. Consider also the possibility of planets with thick, insulating ice layers, where warmth from internal heat sources creates subsurface oceans. These hidden seas, shielded from the harshness of space, could be cradles of life. It's a world of darkness and depth, where bioluminescent creatures might light up the waters in brilliant displays. Can you picture the serene beauty of a glowing sea beneath a frozen surface, a hidden world thriving in silence? Now, let's ponder the role of volcanic activity in shaping habitable environments. On planets with robust tectonic activity, volcanic eruptions could release gases essential for maintaining an atmosphere. These eruptions might also create rich mineral deposits, fueling the growth of life. Picture a landscape sculpted by fire and ash, where life finds a foothold amidst the chaos, thriving in the nutrients provided by the planet's fiery heart. Here's an intriguing notion. Some stars might have habitable zones that shift over time due to changes in their luminosity. As stars mature, their energy output can fluctuate, causing the habitable zone to expand or contract. Life on planets within these zones might evolve to adapt to these changes, developing remarkable resilience and flexibility. It's a testament to the adaptability of life, flourishing in ever-changing conditions. And have you ever thought about the influence of cosmic rays on habitability? While too much radiation can be detrimental, certain levels might drive mutations, accelerating evolutionary processes. On planets with just the right balance, cosmic rays could be a catalyst for diversity, contributing to the tapestry of life. It's a delicate interplay between cosmic forces nudging life along its mysterious path. Consider too the idea of planets orbiting multiple star systems, where complex gravitational forces shape unique orbits. These planets might experience a constantly shifting sky, with multiple stars rising and setting. Imagine the spectacular views, with sunsets painted in hues of gold and crimson, a breathtaking display of cosmic artistry. Such a world might foster life adapted to these ever-changing vistas, creatures as dynamic as the skies they inhabit. Now, let's think about the influence of dust rings surrounding some stars. These rings could act as protective barriers, shielding planets from asteroid impacts and intense radiation. Within these cosmic cocoons, life might flourish, safe from the tumultuous forces of the galaxy. It's like a hidden sanctuary, where serenity prevails amidst the swirling chaos beyond. And finally, imagine the whisper of ancient stardust that forms new planets. Each speck is a fragment of a bygone era, carrying the history of stars that have long since faded. This cosmic dust, merging to create new worlds, holds the seeds of life, a reminder of the universe's infinite cycle of death and rebirth. It's a poetic journey, from stardust to sentience, where life emerges from the remnants of ancient stars, a testament to the timeless dance of the cosmos. Let yourself drift upon these celestial musings, where each fact is a gentle nudge toward endless possibilities, and each star is a beacon guiding you into the depths of space and imagination. Imagine a planet that orbits just on the edge of a star's habitable zone. It's a place where the seasons are extreme, yet life finds a way to thrive in the margins. During its closest approach, imagine vibrant ecosystems awakening, seizing the brief window of warmth. These planets might harbor life forms that are incredibly efficient at capturing and storing energy, preparing for the extended chill as they move farther from their star. Let's dive into the idea of binary star systems. Can you picture a planet caught in the gravitational dance between two stars? The interplay of light and shadow, with two suns casting overlapping halos, creates unique environmental conditions. In such systems, the habitable zone can be complex, where life might need to adapt to the influence of dual suns, each contributing to the rhythm of life in its own way. Speaking of adaptation, consider planets with thick atmospheres rich in reflective clouds. These clouds might serve as a protective shield, reflecting enough starlight to keep surface temperatures within a hospitable range. Beneath these veils, diverse ecosystems could flourish, with organisms evolving intricate relationships with their cloudy canopy. Now, think about the role of magnetic fields. A planet with a strong magnetic field can deflect harmful solar winds and cosmic radiation, providing a safe haven for life. These magnetic shields can also create stunning auroras, dances of light in the sky that might be a nightly spectacle for any life watching from below. Here's something intriguing. Planets in older star systems might have had eons to develop advanced ecosystems. As stars mature and stabilize, the conditions for life might become ideal, giving life forms ample time to evolve complexity and intelligence. Imagine civilizations that have thrived for millions of years, their culture and knowledge as ancient as the stars themselves. Now consider the possibility of rogue planets, those that wander through the galaxy, untethered to any star. If these planets retain heat from their formation or possess internal heat sources, they might harbor life beneath thick layers of ice. Picture a world adrift in the cosmic sea, carrying its own warmth, a solitary refuge in the dark, silent void. And what about planets with dense atmospheres that trap heat in a greenhouse-like effect? This could allow life to exist at much greater ranges from their star, expanding the boundaries of what we consider habitable. In these distant realms, life might bask in the diffuse warmth, evolving under skies that are perpetually shrouded in mist. Have you ever thought about the concept of tidal heating? On planets with eccentric orbits, or those orbiting massive planets, gravitational forces can cause internal friction, generating heat. This process could create liquid water beneath icy surfaces, a hidden ocean teeming with life, warmed by the gentle pull of neighboring celestial bodies. Here's a delightful notion. Planets with rings similar to Saturn, where the interplay of light through icy particles creates shimmering skies. These rings could influence climate and environmental conditions, offering yet another variable in the complex equation of habitability. Life here might evolve to thrive in the glow of rainbow-hued skies, a constant reminder of their world's unique beauty. And speaking of beauty, imagine planets orbiting stars at the edge of our galaxy, where the view of the cosmos is unimpeded by the dense star fields of our galactic core. The night sky would be a tapestry of distant galaxies and nebulae, inspiring awe and wonder in any life gazing upwards. Consider the role of comets and asteroids in delivering essential ingredients for life to planets in habitable zones. These celestial messengers could bring water and organic molecules, seeding worlds with the building blocks of life. It's a cosmic delivery service that plays a crucial role in the genesis of life across the stars. Now, let's explore the idea of planets with mirrored surfaces, where high albedo reflects much of the star's light. These planets, shimmering like cosmic jewels, could maintain cooler climates, supporting life that thrives in gentle temperatures. The reflective surfaces might create dazzling displays of light, a natural spectacle for any inhabitants beneath. Have you heard about the potential for life on planets with thick, insulating atmospheres much like Venus? If these worlds are just right, they might avoid runaway heating, maintaining a delicate balance that allows life to flourish. Beneath dense, swirling clouds, ecosystems could develop in ways we can scarcely imagine, hidden from view yet teeming with vitality. Lastly, ponder the notion of planets with polar ice caps, where seasonal melting creates temporary oceans. This cycle of freeze and thaw could support life adapted to both aquatic and terrestrial environments, a testament to life's adaptability. The ebb and flow of these waters might drive the rhythms of life, a dance of survival in tune with the changing seasons. Let these musings carry you gently into the night, where the wonders of the cosmos lull you into a peaceful reverie. Each fact is a step along the path of discovery, leading you deeper into the mysteries of the universe, where every possibility is an invitation to dream. Did you know that planets orbiting red dwarf stars could experience an entirely different concept of daylight? These stars are much cooler and dimmer than our Sun, which means the planets in their habitable zones are much closer to the star. As a result, the sky might appear in shades of twilight, casting a soft, muted glow over the landscape. You might find life adapted to low-light conditions, thriving under the gentle illumination of their star. Now, consider the phenomenon of planetary migration. Early in a solar system's life, planets can shift from their initial positions, moving closer to or further from their star. This journey could take a planet through various zones of habitability, providing unique evolutionary pressures and opportunities for life to adapt to changing climates over time. Imagine life forms that have witnessed such monumental shifts, their existence deeply intertwined with this cosmic dance. Here's an intriguing thought: habitable zones around variable stars, stars that change in brightness over time, could see fluctuating conditions. Life on such planets might develop unique survival strategies to cope with these changes, perhaps entering periods of dormancy during dim phases and flourishing when the star brightens. This ebb and flow could create a unique rhythm to life, akin to the changing seasons on Earth, but dictated by the star itself. Speaking of rhythms and seasons, picture a planet with an eccentric orbit, where the distance to its star varies significantly. This could lead to dramatic seasonal variations, with intense summers and long cold winters. Life here might need to adapt to extreme temperatures, with some species becoming masters of hibernation, while others evolve to migrate vast distances in search of favorable conditions. And here's something fascinating. Planets in multi-planet systems could be influenced by the gravitational pull of their neighbors. This interaction might stabilize or destabilize a planet's orbit, affecting its climate and habitability. In some cases, these gravitational dances could even increase the potential for life, creating conditions that are just right for a thriving ecosystem. Have you ever imagined what life might be like on planets orbiting pulsars? These rapidly spinning neutron stars emit beams of radiation that sweep across space like lighthouse beams. Although the environment seems hostile, with intense radiation and high-energy particles, there could be niches where life finds a way to endure, perhaps deep underground, or shielded by thick atmospheres. Here's an unexpected twist. Planets with thick atmospheres of hydrogen and helium, similar to gas giants, might actually harbor life. If these atmospheres are stable enough to maintain a warm surface below, the conditions could be suitable for life to develop and thrive. These worlds might resemble enormous versions of Earth, with expansive skies and vibrant ecosystems hidden beneath a gaseous cloak. Consider the possibility of planets in the habitable zones of stars nearing the end of their life cycles, such as red giants. As stars expand, they can heat planets that were once too cold, potentially allowing for a brief interlude where life has a chance to flourish before the star's demise. This fleeting window of habitability could lead to rapid evolution and adaptation, a testament to life's resilience in the face of cosmic change. Now, let's delve into the idea of tidal locking, where one side of a planet always faces its star, similar to how the moon shows only one face to Earth. On such planets, one side is perpetually bathed in daylight, while the other is in constant darkness, the narrow twilight zone in between. With moderate temperatures might be the most likely place for life to thrive, adapting to the stark contrasts of light and dark. Another remarkable concept involves planets with abundant volcanic activity. Volcanism can replenish a planet's atmosphere, releasing gases essential for life and creating diverse habitats, from hot springs to volcanic islands. These dynamic environments might foster unique ecosystems where life thrives amidst the heat and energy of a world in constant transformation. Imagine the impact of moons that influence the habitability of their parent planets. Large moons can stabilize a planet's tilt, moderating its climate and seasons, much like our moon does for Earth. These celestial companions could be crucial for maintaining the delicate balance needed for life. Their influence a quiet guiding hand in the cosmic scheme. And speaking of moons, think about the potential for life on moons themselves, especially those orbiting gas giants in the habitable zone. These moons could have complex geologies and atmospheres, with oceans beneath icy surfaces, warmed by the gravitational interactions with their massive hosts. They offer yet another avenue for life to explore and adapt in the universe. Lastly, consider the role of cosmic winds, the streams of charged particles ejected from stars. These winds can strip planets of their atmospheres, but for those with strong magnetic fields, they might provide nutrients, like cosmic fertilizer. This interaction could be pivotal in determining a planet's capacity to support life, a delicate balance between destruction and enrichment. Let these musings on the myriad possibilities of habitable zones guide you gently into a restful state, where the wonders of the universe become a comforting backdrop to your dreams. Each possibility is a whisper of the cosmos, inviting you to imagine what might be if only we could explore these distant realms. Imagine, if you will, a planet orbiting a binary star system, where two stars dance around one another, casting dual shadows and painting the sky with a celestial ballet. This configuration presents a unique habitable zone that is not a simple ring, but a complex region influenced by the gravitational pull and luminosity of both stars. Life on such a planet would experience a sky with two suns, potentially leading to unique adaptations to cope with the extra light and heat. Now, let me share something intriguing. Planets in eccentric orbits where the distance from their star changes dramatically throughout the year. This can result in extreme temperature fluctuations, where life must rapidly adapt to survive scorching summers and freezing winters. Such resilience might drive the evolution of species capable of entering long periods of dormancy, waiting out the harshest conditions until the environment becomes hospitable again. Speaking of adaptability, consider planets around red dwarf stars. These stars are smaller and cooler than our Sun, meaning their habitable zones are much closer in. Planets in such zones may be tidally locked, with one side always facing the star. In this unique situation, life might thrive in the temperate twilight band between the scorching day side and the freezing night side, where the climate is more stable. Did you know that rogue planets which drift through space without a star might still harbor life? If these planets have thick atmospheres or subsurface oceans, they could retain enough internal heat from planetary formation or radioactive decay to sustain life. Imagine a world shrouded in perpetual darkness, where life relies not on sunlight, but on other sources of energy, perhaps thriving around hydrothermal vents deep beneath the surface. Here's a fascinating thought. Some stars experience significant flaring activity, releasing powerful bursts of radiation. Planets in the habitable zones of such stars might face challenges from these intense flares, which could strip away atmospheres or impact biological molecules. However, life could develop protective mechanisms, such as thick atmospheres or subterranean habitats, to shield against these violent outbursts. Consider the potential of planets orbiting rapidly rotating stars. The fast spin can create strong magnetic fields, which might extend the habitable zone by protecting planets from harmful cosmic radiation. This magnetic cocoon could shelter the nascent life, providing an environment where it can flourish despite the star's energetic nature. Now, imagine a planet with a thick atmosphere, rich in carbon dioxide or methane. Such an atmosphere could act like a greenhouse, trapping heat and potentially extending the habitable zone of a cooler star. Life on this planet might evolve to cope with high-pressure environments, developing unique ways to process and utilize the abundant gases. And here's something unexpected. Habitable zones aren't just limited to stars and planets. Entire galaxies have regions where conditions may be just right for life, known as galactic habitable zones. Factors such as the density of stars, the prevalence of heavy elements, and the likelihood of catastrophic events like supernovae play a role. Life in these zones might benefit from a stable environment, with ample resources to foster complexity over billions of years. Speaking of complexity, binary star systems might host planets that experience unique gravitational interactions, creating dynamic climates. These interactions could lead to complex weather patterns, where life must adapt to constantly changing conditions, perhaps evolving rapidly to take advantage of the ever-shifting environment. Imagine the influence of stellar winds on a planet's atmosphere. These streams of charged particles can strip away lighter gases, potentially transforming a planet's climate over time. Planets with strong magnetic fields might retain their atmospheres, while those without could see them eroded away, leading to a barren landscape. Life on such planets might need to find refuge in subterranean caves or under thick ice layers, protected from the relentless stellar winds. Did you ever consider the role of planetary composition in habitability? Planets rich in heavy elements might retain heat better, providing a stable internal environment for life. On the other hand, planets with light, volatile elements could see dramatic surface changes, influencing the evolution of life by creating diverse and challenging habitats. Here's a curious notion. Planets with significant axial tilt could experience pronounced seasonal changes, with life adapting to survive under varying conditions. For instance, species might develop strategies to endure harsh winters or take advantage of abundant resources during fleeting summers. Imagine the potential for life on planets with surfaces covered in vast oceans, where the habitable zone includes not just the land, but the entire water column. In such aquatic worlds, life might evolve to exploit the three-dimensional environment, developing complex ecosystems that thrive from the sunlit surface to the dark depths. Finally, consider the delicate balance required to maintain a habitable zone over billions of years. Stars gradually change as they age, often expanding and brightening, which can shift the habitable zone outwards. Life on a planet in such a system may need to adapt quickly to new conditions or face extinction. This cosmic dance of change and adaptation underscores the resilience and tenacity of life in the universe, ever seeking new ways to flourish amidst the stars. Let me paint a picture for you. Imagine a planet orbiting a pulsar, those fascinating remnants of massive stars that emit beams of radiation as they spin. While pulsars might seem inhospitable with their intense radiation, some scientists speculate that planets with thick atmospheres or magnetic fields could potentially shield life from the harmful rays. In such an environment, life might develop unique adaptations to filter or even harness the energy from the pulsar's beams. Here's something intriguing. The speed at which a planet rotates can significantly influence its climate and habitability. A planet with a rapid rotation could have shortened days and nights, resulting in milder temperature fluctuations. This could create a more stable environment for life to thrive, as extreme temperatures are moderated by the swift transition from day to night. Imagine a world where life has evolved to dance to the rhythm of these brief, constant cycles. Speaking of rhythms, did you know that the size of a planet can also play a crucial role in its potential habitability? Larger planets, known as super-Earths, could possess stronger gravitational pulls, which might help them retain thick, life-supporting atmospheres. These atmospheres could moderate the planet's temperature and protect it from harmful cosmic rays, providing a nurturing environment for life to flourish. Now, consider the potential for habitable zones around double star systems, where two stars orbit each other while planets orbit them both. Such planets might experience two dawns and two dusks, with the combined light of both stars extending the habitable zone further out than it would be with a single star. This could create a unique environment where life would need to adapt to the unusual light patterns and potentially varying climate conditions. Imagine a world where the presence of moons plays a significant role in habitability. Moons can have a stabilizing effect on a planet's axial tilt, which in turn stabilizes its climate. This would mitigate extreme seasonal changes, creating a more predictable environment for life. In addition, some moons might themselves be candidates for life if they harbor subsurface oceans warmed by tidal heating from their parent planet's gravitational pull. Here's a surprising thought. Not all habitable zones need to orbit stars. Brown dwarfs, often considered failed stars because they lack the mass to sustain hydrogen fusion, can still emit enough heat to create habitable conditions for planets in close proximity. These planets might receive just enough warmth from their dim companion to support liquid water on their surfaces, expanding our understanding of where life could potentially arise. Consider the concept of atmospheric pressure and its impact on habitability. A planet with a high atmospheric pressure might have the ability to keep water in a liquid state over a wider range of temperatures. This could allow life to exist even in regions that would otherwise be too cold or too hot, as the pressure helps stabilize the conditions needed for water to remain liquid. Did you ever wonder about the influence of meteoritic and cometary impacts on habitability? While these impacts can be devastating, they also have the potential to deliver water and organic compounds to a planet, kickstarting the development of life. Over time, these celestial deliveries could enrich a planet's chemistry, providing essential ingredients for life to begin and evolve. Imagine a scenario where the presence of volcanoes on a planet plays a crucial role in maintaining a habitable climate. Volcanic activity can release gases like carbon dioxide and water vapor, contributing to a greenhouse effect that warms the planet. This process can help maintain liquid water and a stable climate even if the planet receives less sunlight, showcasing the delicate balance required to sustain life. Speaking of balance, the presence of tectonic activity is another factor that can influence habitability. Tectonics can recycle carbon dioxide through the process of subduction and volcanic eruptions, regulating the planet's climate over long timescales. This constant renewal of the surface can also create diverse habitats and ecosystems, offering numerous niches for life to explore. And here's a thought-provoking idea. The color of a star can influence the photosynthetic processes of plants on orbiting planets. Planets around red dwarfs might develop vegetation that absorbs different wavelengths of light than we see on Earth, possibly resulting in plants with hues of black or deep purple instead of green. This adaptation would maximize their ability to capture the available light for energy. Finally, let me share the intriguing possibility of planets experiencing periodic ice ages. These cycles, driven by variations in a planet's orbit and axial tilt, could lead to significant evolutionary pressures on life. Species might need to develop strategies to cope with extended cold periods, such as hibernation or migration, adding to the rich tapestry of life's adaptability in the universe. As we ponder these diverse and surprising aspects of habitable zones, it's a testament to the resilience and creativity of life, forever seeking new frontiers in which to thrive. These cosmic possibilities remind us of the vastness and wonder of the universe, inviting us to dream of the myriad forms life might take beyond our home planet. As we continue our exploration of habitable zones, let's delve into the fascinating world of planetary atmospheres. Did you know that a planet's atmosphere can act as a protective shield against solar radiation? This atmospheric layer absorbs and scatters the high-energy particles from its star, preventing them from reaching the surface and causing harm to potential life forms. It's amazing to think how such an invisible barrier can create a safe haven for life to develop. Now let's think about magnetic fields. A planet with a strong magnetic field can deflect solar winds, which are streams of charged particles emitted by a star. These winds can strip away a planet's atmosphere over time, but a magnetic field offers a line of defense, preserving the atmosphere and its potential to support life. Imagine a world where the magnetic shield is a vital component of the planet's survival strategy. Speaking of survival, let's consider the role of a star's variability in habitability. Some stars, particularly young ones, can be quite erratic, with frequent flares that release bursts of radiation. Planets orbiting these stars must endure these outbursts, which can impact atmospheric composition and surface conditions. Life on such planets might need to develop protective mechanisms or retreat underground during periods of increased stellar activity. Here's something you might find captivating: the presence of a hydrogen greenhouse effect. On some planets, a thick hydrogen atmosphere can trap heat efficiently, keeping the surface warm even if the planet is located far from its star. This intriguing phenomenon could extend the habitable zone much farther than previously thought, suggesting that life could exist in more distant, colder regions of a star system. Imagine for a moment tidal locking and its implications for habitability. When a planet is tidally locked to its star, one side always faces the star, while the other remains in perpetual darkness. This results in extreme temperature differences between the two sides. However, life could still find a way to adapt, perhaps by thriving in the twilight region, where temperatures might be more moderate. The contrast between light and dark might create unique ecosystems, each with its own adaptive strategies. Let me share with you the intriguing possibility of life on planets orbiting stars that are nearing the end of their life cycle. As a star like our Sun ages and expands into a red giant, its habitable zone shifts outward. Planets previously too distant and cold might suddenly find themselves in the warm embrace of this expanded zone, potentially awakening dormant life or sparking the evolution of new forms. It's a captivating reminder of the ever-changing nature of the universe. And here's a thought-provoking idea. the role of ultraviolet light in driving chemical reactions. While too much ultraviolet can be harmful, low levels can actually facilitate the formation of complex organic molecules, which are the building blocks of life. This delicate balance of light and chemistry might be crucial for the emergence of life, adding another layer to the intricate dance of factors that influence habitability. Speaking of chemistry, consider the impact of different elements in a planet's atmosphere. For instance, an abundance of carbon dioxide can lead to a strong greenhouse effect, while the presence of oxygen might indicate biological activity. The interplay of these elements can shape a planet's climate and potentially signal the presence of life. It's a fascinating puzzle, each piece offering clues about the planet's potential to host life. Have you ever wondered about the influence of planetary rings on habitability? Rings composed of ice and rock can reflect light and heat, potentially affecting the climate of the planets they orbit. These rings might also contribute to the planet's magnetic field, or even serve as a source of materials for building atmospheres or supporting life. The sight of a ringed planet in the night sky would be a breathtaking reminder of the complexity and beauty of the universe. Now, let's contemplate the role of water vapor in a planet's atmosphere. Water vapor is a potent greenhouse gas, capable of trapping heat and warming the planet. This means that even small amounts of water vapor can have a significant impact on climate, potentially creating habitable conditions where none would otherwise exist. In this way, the presence of water vapor can be a key factor in determining whether a planet lies within the habitable zone. Consider the curious influence of planetary albedo, which is a measure of how much light a planet reflects. A high albedo, due to clouds, ice, or surface composition, means more light is reflected, leading to cooler temperatures. Conversely, a low albedo means the planet absorbs more heat, warming its surface. This balance of reflection and absorption can dramatically alter a planet's climate, influencing its potential to support life. On a similar note, think about the intriguing role of clouds in moderating a planet's climate. Clouds can reflect sunlight, helping to cool the planet, while also trapping heat, contributing to warming. This delicate balance can create stable conditions conducive to life, demonstrating yet another way nature orchestrates a symphony of factors to nurture habitability. Finally, let's ponder the potential for life in subsurface environments. Some planets, even those outside traditional habitable zones, might harbor liquid water beneath their surfaces, kept warm by geothermal activity. These hidden oceans could provide a refuge for life, protected from harsh surface conditions. It's a humbling thought that life could thrive in such secluded places, hidden from view yet vibrant and dynamic. Let's delve into the fascinating concept of binary star systems. Imagine a planet orbiting not just one, but two stars. These systems, known as circumbinary systems, offer a unique set of challenges and opportunities for habitability. Depending on the distance and orbital dynamics, the habitable zone in such systems can be surprisingly stable or incredibly complex. The interplay of gravitational forces from two stars can create a dance of orbits, leading to varying levels of solar radiation that could significantly impact the climate and potential for life. It's a cosmic ballet that invites us to reconsider our notions of stability and habitability. Have you ever considered the role of metallicity in a star's ability to host habitable planets? Metallicity refers to the abundance of elements heavier than hydrogen and helium in a star. A higher metallicity means there are more building blocks available for planet formation. This abundance can lead to the creation of rocky planets with rich, diverse structures, enhancing the chances of finding planets within the habitable zone. It's a reminder of how the tiniest details in a star's composition can ripple outwards, influencing entire planetary systems. Speaking of star types, think about the intriguing nature of red dwarf stars. These small, cool stars are the most common in our galaxy, and they have incredibly long lifespans, often lasting tens of billions of years. This longevity offers an extended window for potential life to develop and evolve. However, the habitable zones around red dwarfs are much closer to the star, which could expose planets to intense stellar activity. Despite this, their abundance makes them prime targets in the search for habitable worlds. Here's a captivating thought: the influence of stellar winds on a planet's habitability. Stellar winds, streams of charged particles emitted by a star, can strip away a planet's atmosphere over time. Yet, these winds can also play a role in shaping magnetic fields and redistributing atmospheric gases, potentially aiding in climate regulation. The interaction between stellar winds and planetary atmospheres is a delicate balance, one that showcases the dynamic relationship between a star and its orbiting worlds. Consider the fascinating concept of Goldilocks zones that extend beyond traditional habitable zones. In some systems, moons orbiting gas giants could find themselves in these extended habitable regions. These moons might benefit from geothermal heat due to tidal forces exerted by their parent planet, creating conditions where liquid water. It highlights how habitability isn't restricted to planets alone, expanding our search for life to include other celestial bodies. Did you know that some stars experience cycles of activity not unlike our sun's sunspot cycles? These cycles can influence the amount of radiation a planet receives, causing fluctuations in climate over time. Understanding these cycles can provide insight into long-term climate stability and the potential for life to adapt to changing conditions. It's a reminder of the dynamic nature of star systems, where even subtle changes can have profound impacts on planetary environments. Now, let's think about the fascinating role of stellar flares in shaping planetary atmospheres. While often seen as destructive, these flares can also deliver bursts of energy that might drive complex chemical reactions, potentially aiding in the development of prebiotic chemistry. It's a paradoxical relationship where destruction and creation go hand in hand, illustrating the complex interplay of forces that can foster the seeds of life. Have you pondered the concept of eccentric habitable zones? Some planets move in elongated orbits, causing them to swing in and out of their star's habitable zone. This changing proximity can lead to dramatic shifts in climate, from searing heat to deep freeze. Yet, these variations could also stimulate evolutionary pressures, driving life to adapt in unique and resilient ways. This cyclical exposure to diverse conditions could cultivate a rich tapestry of life, each species uniquely adapted to its fluctuating environment. And here's an intriguing thought: the potential for habitability in systems with multiple planets. In such systems, planets can influence each other's orbits through gravitational interactions. These influences can stabilize or destabilize climates, affecting the potential for life on any given planet. Multi-planet systems provide a complex web of gravitational relationships, each thread contributing to the overall harmony or discord of the system's habitability. Have you ever considered the impact of a star's age on its habitable zone? As a star evolves, its luminosity changes, shifting the habitable zone over time. Planets might begin their journey outside this zone, only to move into it as the star matures. This dynamic process means that habitability is not a fixed state, but a journey across time, where the potential for life ebbs and flows with the life cycle of the star. Finally, let's not forget the intriguing notion of atmospheric escape. Over time, lighter gases in a planet's atmosphere can escape into space, altering the composition and potentially the climate. This process can lead to the loss of water vapor, essential for life, or conversely the retention of heavier, life-supporting gases. Understanding this delicate balance helps us appreciate the fragility and resilience of planetary atmospheres and the life they may support. Each of these factors, from gravitational interactions to stellar compositions, weaves a complex tapestry that defines the potential for habitability in the vast universe. Let me guide you into the subtleties of a star's rotation and its impact on the habitable zone. When a star rotates rapidly, it can affect the distribution of heat and radiation emitted to its surrounding planets. This variation can create a more complex climate pattern, influencing the potential for life in surprising ways. Imagine how a planet's day length might adjust to adapt to the erratic rhythm of its star's spin, showcasing nature's incredible flexibility. Here's a surprising aspect: the role of binary star systems in enhancing or challenging habitability. In these systems, two stars orbit one another, creating a dynamic environment for any planets within their gravitational influence. Depending on the configuration, a planet might orbit just one star, both stars, or switch between them, each scenario posing unique challenges and opportunities for life. The shifting gravitational forces can lead to unusual climate patterns, pushing life to evolve in innovative directions. Have you ever considered the influence of a star's magnetic field on its planets? A strong stellar magnetic field can shield planets from harmful cosmic radiation, enhancing the conditions for life. At the same time, this magnetic protection can interact with a planet's own magnetic field, creating auroras and other atmospheric phenomena that might contribute to the planet's habitability. It's a dance of electrical forces that adds another layer of protection and beauty to these distant worlds. Speaking of protection, let's delve into the shielding effect of planetary rings. Some planets possess spectacular rings composed of ice and rock particles, and these can provide a surprising form of protection by blocking some of the harmful radiation from their star. In doing so, they contribute to maintaining a more stable climate, making the planet's surface more hospitable. It's a natural barrier that might play a crucial role in the delicate balance of life-supporting conditions. Did you know that the presence of volatiles like water, carbon dioxide, and ammonia can extend or constrict a habitable zone? These substances influence a planet's climate by altering the greenhouse effect, either warming the planet or cooling it down. The delicate interplay of volatiles within a planet's atmosphere can lead to a wide range of climates, from tropical paradises to icy wastelands, expanding or limiting the potential for life to thrive. The wonders of tidal locking offer another intriguing dimension. When a planet is tidally locked to its star, one side perpetually faces the star while the other remains in darkness. This can lead to stark temperature differences across the planet. However, the twilight zones between the day and night sides could provide a unique environment where life might flourish, sheltered from the extremes of heat and cold. This intriguing possibility invites us to imagine life adapting to a narrow band of perpetual dusk. Let me share something interesting about the gravitational pull of a star on its planets. This force can generate tidal heating, where the constant flexing of a planet's interior generates heat. This internal warmth can create subsurface oceans beneath icy crusts, offering a hidden sanctuary for life. It's fascinating to think that beneath a seemingly frozen surface, a vibrant ecosystem could thrive, untouched by the harshness of space. Speaking of hidden wonders, consider the prospect of subterranean life driven by geothermal energy. In planets with active geology, internal heat can create pockets of liquid water and rich mineral environments beneath the surface. These hidden worlds might harbor life forms that have evolved entirely independent of sunlight, relying instead on the warmth and nutrients provided by the planet's interior. It's a reminder of the resilience and adaptability of life in the face of isolation. Here's a captivating thought: the potential influence of cosmic rays on a planet's atmosphere. These high-energy particles can trigger chemical reactions in the upper atmosphere, leading to the formation of complex organic molecules. Over time, these molecules might rain down onto the surface, seeding it with the building blocks of life. It's a cosmic alchemy where the universe's most powerful particles become creators, not just destroyers. The concept of planetary migration adds another layer of complexity to habitable zones. Planets can shift their orbits over time due to gravitational interactions with other bodies, potentially relocating from inhospitable regions to the sweet spot of habitability. This migratory journey might allow life to begin in a challenging environment before finding a more stable home, illustrating the dynamic and ever-changing nature of planetary systems. Consider the role of a planet's axial tilt, or obliquity, in shaping its climate. A significant tilt can lead to pronounced seasonal changes, while a gentle tilt might result in a more stable climate. These variations influence the distribution of sunlight and, consequently, the potential for diverse ecosystems to emerge. The tilt of a planet is like a cosmic metronome, setting the rhythm for life to dance to. Let me guide you into the fascinating interplay between a planet's size and its ability to retain an atmosphere. Larger planets have stronger gravity, which helps them hold on to thicker atmospheres, potentially creating more temperate conditions. On the other hand, smaller planets may struggle to retain their atmospheres, leading to harsher environments. This delicate balance between size and atmospheric retention plays a crucial role in determining a planet's habitability. Have you ever imagined the potential for habitability in rogue planets, those wandering worlds not bound to any star? These mysterious planets might retain enough internal heat to support subsurface oceans, offering a refuge for life hidden from the light of the stars. Rogue planets challenge our traditional notions of habitability, reminding us that life might find a way even in the cold, dark reaches of interstellar space. Finally, let's ponder the impact of stellar metallicity on the diversity of planetary systems. Stars rich in metals are more likely to host a variety of planets, from gas giants to rocky worlds like Earth. This diversity enhances the chances of finding planets within the habitable zone, expanding the opportunities for life to emerge. The metallic content of a star serves as a cosmic recipe, determining the ingredients available for the formation of planets and, potentially, life. As we explore these myriad factors, it becomes clear that the search for habitable worlds is a journey filled with wonders and surprises, each discovery revealing a universe brimming with potential. As a star matures, it gradually becomes brighter and hotter, which means its habitable zone shifts outward over time. This slow transformation can lead to a once habitable planet becoming too hot, or a previously icy world warming up to support life. It's as if the star's life cycle is a cosmic dance, with planets adjusting their orbits in a delicate equilibrium to keep in step. Imagine the intriguing case of binary star systems, where two stars orbit a common center. These systems can present not one, but multiple habitable zones, offering complex gravitational interactions that might allow planets to orbit one or both stars. The presence of two suns in the sky could create dynamic and varied climates where life might thrive under the glow of double sunsets. Picture the unique adaptations that life forms might develop in such a dual star environment. Here's a surprising fact. The width of a habitable zone is influenced not only by the star's mass, but also by its luminosity. Smaller, dimmer stars, known as red dwarfs, have narrower habitable zones that are closer to the star. In contrast, large, bright stars have wider zones that stretch farther out. This variation means that the type of star greatly affects where planets with temperate climates might be found, shaping the search for life in the cosmos. Speaking of red dwarfs, these stars are the most common in the galaxy, and their habitable zones are of particular interest. Despite their lower energy output, red dwarfs are known for their longevity, often burning steadily for tens of billions of years. This extended lifespan could provide a stable environment for life to develop and evolve over much longer timescales. Imagine the evolutionary possibilities on a planet orbiting such a patient, enduring sun. Have you ever considered the role of magnetic fields in determining a planet's potential habitability? A strong magnetic field can protect a planet from stellar winds that might otherwise strip away its atmosphere. This invisible shield allows the atmosphere to remain intact, preserving the conditions necessary for liquid water and life. Without such protection, a planet could become barren and lifeless, illustrating how even unseen forces play a pivotal role in the grand tapestry of habitability. Let me share something intriguing about stellar flares, which are powerful bursts of energy that some stars emit. These flares can significantly impact planets in close proximity, particularly those in the habitable zones of volatile stars like red dwarfs. Frequent flaring can strip away atmospheres or cause surface conditions to fluctuate wildly, challenging any life that might attempt to take root. Yet, if life can adapt to such extreme variability, it could become remarkably resilient and diverse. Did you know that the presence of other planets in a star system can influence the stability of a habitable zone? Massive planets like gas giants may gravitationally influence their neighboring worlds, potentially ejecting them from stable orbits or shepherding them into more favorable positions. This cosmic ballet can lead to unexpected outcomes, where a planet's path to habitability is choreographed by the gravitational pull of its larger siblings. Consider the fascinating case of planets with thick atmospheres composed mainly of hydrogen and helium. Such atmospheres can trap heat efficiently, extending the habitable zone of a planet beyond what would be expected based purely on distance from the star. These greenhouse worlds could support life in conditions that might otherwise be too cold, showcasing the creative possibilities nature employs in the quest for habitability. You might be surprised to learn about the role of planetary rings in shaping habitability. Rings made of ice and rock can reflect sunlight, altering the climate of the planets they encircle. They can also affect the distribution of heat, potentially creating unique microclimates where life might find a niche. While we often admire the beauty of rings from afar, they could play a more integral role in supporting life than we realize. Have you ever thought about the importance of a planet's rotation rate in determining its habitability? A slower rotation might equalize temperatures between the day and night sides, creating more stable climates across the globe. Conversely, a rapid spin can lead to extreme weather patterns with intense storms and high winds. The rotation rate adds yet another dimension to the complex puzzle of planetary habitability, influencing how life could emerge and adapt. Here's a captivating thought: the concept of ice belts in relation to habitable zones. In some planetary systems, Belts of ice might exist beyond the habitable zone, but could be drawn inward by gravitational forces, delivering essential water to rocky planets. This delivery system can create the conditions necessary for life, showcasing a celestial mechanism of resource distribution. The idea of cosmic logistics, where water is ferried across vast distances, is truly awe-inspiring. Speaking of resources, consider the role of comets and asteroids in seeding planets with the building blocks of life. These celestial bodies often originate from regions beyond the habitable zone, but might collide with planets delivering water and organic compounds. This process, known as panspermia, suggests that life could spread between distant worlds, painting a picture of a universe connected not just by gravity, but by the potential for life to flourish. Finally, imagine the potential for life in multi-star systems, where planets experience varying levels of heat and light. These dynamic environments might lead to the development of life forms capable of adapting to a wide range of conditions, thriving when one star is prominent and surviving when another takes over. The adaptability required in such a fluctuating setting challenges our understanding of life's resilience and hints at the incredible diversity that might exist beyond Earth. Speaking of multi-star systems, have you ever wondered about the possibility of habitable worlds orbiting binary stars? These systems can present unique challenges, as the gravitational dance between the stars can create complex orbital dynamics for any planets caught in their pull. Yet, such a configuration could also lead to worlds with stunningly diverse climates, experiencing intense sunrises and sunsets as each star takes its turn in the sky. Imagine the beauty of a twin-star sunset, painting the landscape with colors never before seen. Let me share something fascinating about the notion of tidally locked planets, where one side always faces the star, while the other remains in perpetual darkness. You might think this setup would be too extreme for life, but the twilight zone, a region between light and dark, could offer a narrow band of habitability. In this area, temperatures might be just right for life to thrive, offering a unique environment where adaptation is key to survival. This reminds me of the idea that liquid water, crucial for life as we know it, might not always be a certainty even within the habitable zone. For planets around particularly active stars, the presence of water could depend heavily on atmospheric retention and geological activity. Without these protective features, water might be lost to space, leaving the surface dry and inhospitable. Speaking of geological activity, here's a captivating idea. Volcanic activity could play a critical role in maintaining surface conditions conducive to life. Volcanoes can release gases that form atmospheres or replenish them, shielding a planet from harmful radiation and maintaining temperatures suitable for liquid water. It's a delicate balance, and without such activity, a world might quickly become barren and lifeless. Did you know that the position of a planet's orbit within the habitable zone can dramatically alter its potential for supporting life? Planets on the inner edge might experience greenhouse effects that could lead to runaway heating, whereas those on the outer edge might encounter freezing conditions. The sweet spot, where conditions are just right, can be surprisingly narrow, highlighting the fine line between habitability and harshness. Can you imagine a world where the concept of habitability is influenced by the presence of a moon? Moons can stabilize a planet's axial tilt, which affects seasonal variations and climate stability. Without a moon, a planet might experience erratic climate shifts, making it much harder for life to gain a foothold. The interplay between a planet and its moon can be crucial for fostering a nurturing environment. Let me tell you about the role of molecular clouds in the formation of habitable worlds. These vast regions of gas and dust are the birthplaces of stars and planets. As a star forms, the surrounding material can coalesce into planets, with the possibility of water and organic molecules included from the start. This initial abundance of life's building blocks sets the stage for habitability even before a planet finds its place in the habitable zone. Speaking of life's building blocks, consider the intriguing notion that stars themselves might influence the chemistry of their planets' atmospheres. Stars emit different types of radiation that can drive chemical reactions in planetary atmospheres, leading to the formation of complex organic molecules. These processes might occur far from the habitable zone, yet still provide the seeds for life if conditions later become favorable. Here's an interesting thought. Some stars, known as variable stars, undergo periodic changes in brightness. For planets within the habitable zone of such stars, these fluctuations might cause climate cycles that challenge life to be incredibly adaptable. Imagine life forms that can endure extended periods of darkness or unexpected bursts of solar energy, evolving strategies to survive in a constantly shifting environment. Did you ever consider the possibility of underground life on planets within the habitable zone? Even if surface conditions are hostile, subsurface habitats might offer stability and protection from radiation. Life could thrive in underground lakes or warm pockets heated by geothermal activity, hidden from our view yet resilient and diverse. This brings us to the concept of planetary magnetospheres, which are created by a planet's magnetic field. These protective bubbles can shield a planet's atmosphere from being stripped away by stellar winds and cosmic rays. In their absence, life might have to retreat underground or develop protective mechanisms to endure harsh surface conditions. Speaking of protection, here's a thought-provoking idea. Comet showers can periodically bring fresh material to planets, potentially delivering water and organic compounds. These cosmic events could rejuvenate planets that have lost their atmospheres or surface water, offering new opportunities for life to take hold. As we ponder the myriad ways in which habitable zones can manifest around stars, it's humbling to realize the intricacies involved in creating a nurturing environment for life. From gravitational influences to atmospheric dynamics, each element plays a role in the delicate symphony of habitability. The universe, in its vastness, holds countless secrets waiting to be discovered, inviting us to imagine the endless possibilities that exist beyond our world. In the quiet moments of reflection, as stars twinkle overhead, we are reminded of our connection to the cosmos and the shared potential for life that spans the galaxies. Let me share with you a fascinating insight about rogue planets, those mysterious wanderers of the galaxy. Unlike planets tethered to a star, rogue planets drift through space, yet they might still harbor life. Can you imagine a world where heat emanates not from a distant sun, but from the planet's own geothermal activity? These solitary worlds could maintain subsurface oceans and ecosystems, warmed by the planet's internal heat, hidden away in the vast cosmic darkness. Speaking of warmth from within, did you know that a planet's core composition can influence its habitability? The presence of elements like iron and nickel can sustain a molten core, which in turn generates a magnetic field. This magnetic field can be crucial, offering protection from cosmic radiation and aiding in the retention of a planet's atmosphere. Without such a core, a planet might struggle to hold on to the very air we imagine might sustain life. It's intriguing to consider that not all stars burn with the same intensity. Red dwarf stars, for instance, are smaller and cooler than our Sun, which means their habitable zones are much closer in. But here's the catch. These stars often exhibit intense flares that can strip away a planet's atmosphere. For life to persist around a red dwarf, it would need to be exceptionally resilient or deeply protected from the stellar outbursts. Let me tell you about the potential of multiple star systems. In such systems, a planet might orbit around more than one star, experiencing complex gravitational interactions. While this dance might seem chaotic, it can actually stabilize a planet's orbit, keeping it consistently within the habitable zone. Imagine the spectacular skies of such a world, adorned with multiple suns rising and setting, each contributing to the planet's climate. Here's an interesting thought. The speed at which a planet rotates can affect its habitability. Rapid rotation often leads to stronger magnetic fields and more pronounced weather patterns, which can help distribute heat more evenly across the planet's surface. This could mean the difference between a blistering desert and a temperate paradise, simply due to the planet's spin. Did you know that the chemical composition of a star can also dictate the potential for life on its planets? Stars rich in heavy elements might form planets with diverse mineral compositions, some of which are essential for life. A star's metallicity, as it's called, can thus be a key factor, setting the stage for the development of planets with complex geology and chemistry. Consider the allure of cosmic collisions. While it might sound destructive, the impact of large asteroids or comets can actually jumpstart processes critical for life. These collisions can deliver water and organic compounds, as well as create new environments through the heat and pressure they generate. In the aftermath, life might find new opportunities to flourish, adapting to the altered landscape. It's fascinating to think about how variations in axial tilt could shape life on a planet. A slight tilt might lead to gentle seasons, while an extreme tilt could create harsh climatic swings. Yet, life is tenacious and could evolve specialized strategies to cope with or even exploit these constant changes, leading to unique adaptations and ecological niches. Here's another captivating idea. The color of a planet's sky could vary greatly depending on its atmosphere and the light from its star. Imagine a world where the sky is a deep purple or a brilliant green, shaped by atmospheric particles and the star's spectral output. Such a variance could affect not only the aesthetics but also the energy available for photosynthesis, influencing the kind of life that might develop. Did you ever wonder about the potential role of distant stars in creating habitable conditions? Gravitational interactions with neighboring stars, particularly in dense star clusters, could adjust the orbits of planets, nudging them into or out of habitable zones. These cosmic pushes and pulls might occasionally bring new opportunities for life, or render a planet inhospitable in the blink of an astronomical eye. Let me share something intriguing about the role of ice. On planets or moons with extensive ice caps, the melting and refreezing of ice can drive ocean currents, facilitating nutrient mixing and creating conditions that support diverse marine ecosystems. Beneath the icy surfaces, entire worlds could exist, vibrant and teeming with life, yet hidden from the harsh realities above. Wind patterns, driven by a star's energy, can spread warmth from the day side of a tidally locked planet to its night side, creating a more uniform climate. This intricate dance of air currents could make a seemingly inhospitable world surprisingly habitable, with gentle breezes carrying life-sustaining warmth across the planet. Reflecting on these myriad possibilities, we are reminded once more of the delicate balance that makes habitability possible. Each planet, with its unique set of conditions, tells a story of potential. As we drift into dreams, let the cosmos inspire us with its vastness and its promise of life beyond our own familiar shores. The universe, with its infinite potential, beckons us to wander and explore one starry night at a time. Let's continue our journey into the captivating world of habitable zones and the secrets they hold. Imagine a world where the presence of massive gas giants could act as guardians, protecting smaller, potentially habitable worlds from frequent asteroid impacts. These giant planets can act like cosmic vacuum cleaners, their strong gravitational pull attracting or deflecting hazardous objects that might otherwise disrupt the delicate balance of a habitable environment. Speaking of protection, did you know that a thick atmosphere can serve as a planet's shield against harmful radiation? A dense layer of gases can absorb and scatter incoming ultraviolet and cosmic rays, creating a protective barrier that allows life to thrive beneath. This atmospheric shield, much like a cozy blanket, can regulate temperatures and even redistribute heat across the globe, contributing to more stable climates. Here's an intriguing thought. Some planets might have oceans beneath thick layers of ice, hidden from the surface but kept liquid by geothermal heat. These subsurface oceans could be teeming with life, isolated from the surface but rich with nutrients and energy sources. It's fascinating to envision entire ecosystems thriving in these dark, hidden realms, far from the light of their star, yet very much alive. Have you ever considered the role of a planet's size in determining its ability to support life? Larger planets, with their greater gravitational pull, are more likely to retain a dense atmosphere, which can be crucial for maintaining surface water and regulating temperature. However, if a planet is too large, it might become a gas giant, with crushing pressures and inhospitable conditions. The balance of size is delicate, and each planet walks this tightrope of habitability with its own unique flair. Speaking of unique conditions, there are places in our universe where binary stars dance together, and a planet might orbit both. In such systems, a planet could experience two sunrises and sunsets, creating a dynamic environment influenced by the duality of its stars. The gravitational interplay in these systems can be complex, but it also offers stability that might support the development of life. Here's a fascinating idea. The age of a star can influence the habitability of its planets. Younger stars tend to be more volatile, with frequent flares and high-energy emissions that can strip away atmospheres. As stars age, they generally stabilize, providing a more consistent environment for life to develop. However, older stars might swell and cool, changing the boundaries of their habitable zones over time, so life must continually adapt to these slow cosmic changes. Let me share something surprising about the chemistry of atmospheres. A planet with an atmosphere rich in carbon dioxide could promote a greenhouse effect, trapping heat and warming the planet's surface. But too much of this gas can lead to runaway heating, transforming a potentially habitable world into a hothouse like Venus. The balance of gases is crucial, where even the slightest alteration could tip the scales between paradise and perdition. Can you imagine a world where the presence of moons plays a significant role in fostering life? Large moons can stabilize a planet's axial tilt, preventing drastic climate shifts that might otherwise be catastrophic. Moreover, the gravitational pull of a moon could drive tidal forces, encouraging the mixing of ocean waters and supporting the complexity and diversity of ecosystems below. Did you ever think about the importance of a planet's magnetic field in maintaining habitability? A strong magnetic field can deflect solar winds, preventing them from eroding the atmosphere. This magnetic shield helps to protect the crucial elements of life, like water and oxygen, ensuring they remain in the atmosphere rather than being stripped away into space. And speaking of atmospheres, The presence of clouds can have a profound impact on a planet's climate. Clouds can reflect sunlight, cooling the surface, or trap heat below, acting as a blanket. The composition and distribution of clouds, driven by complex meteorological patterns, can create diverse climates and weather systems, each offering unique niches for life to flourish. Consider this: the eccentricity of a planet's orbit, or how elliptical it is, can influence the climate over time. A highly elliptical orbit might cause extreme seasonal changes, while a more circular orbit offers stability and predictability. Life in such environments would need to be adaptable, constantly shifting with the changing seasons, and learning to thrive in both abundance and scarcity. Isn't it fascinating to think about how the cycle of day and night affects planet-wide conditions? On a planet with a longer day-night cycle, temperatures might swing more dramatically, encouraging the development of unique survival strategies among its inhabitants. On the other hand, planets with short cycles might have more uniform climates, offering consistency to the life forms that call them home. Finally, let's ponder the possibility of exotic climates driven by unusual star types. Stars that emit more infrared radiation could warm planets in unexpected ways, influencing the development of life forms adapted to different energy sources. These worlds might look vastly different from anything we've imagined, yet they hold the promise of life, adapting to the peculiarities of their nurturing stars. As the vastness of the cosmos envelops us like a gentle embrace, we're reminded of the infinite possibilities that stretch beyond our night sky. Each star, with its unique characteristics, holds the potential to host worlds unlike any we have ever imagined. Dream well, dear traveler, as the universe continues to spin its tales of wonder and possibility.